Gentlemen, if you've parked your vehicle on level 1 car park, please move to level 2 urgently. In particular, yellow Getz 01 sits RDJ, silver Saab 11 sits VPM, black Ford 3 sits 4 TVK, silver Jeep 519 RWL, gunmetal BMW ZZC 135, silver Lancer 623 LIR, white Polo QMH 86, gunmetal Suzuki 044WOJ, white QO Renault 480 XAZ, red Subaru 846WAL, black Insignia 312 THZ, black CX9 327WRN, white Discovery 723WHP, black Toyota GRO 635, white Hyundai 364 JHR, and a silver 130 80XYX. Thank you.
All right, yeah, let's get the show on the road. So first of all, thank you very much for everyone coming along and attending. So my name is Russ Cam. I'm a software engineer at Elastic, and today I'm going to be talking about building out an ARM template to deploy a complex distributed system, complex beast like Elasticsearch to Azure. So first of all, hello, or hello world, or hello Ignite. So why am I here and why am I talking to you about this? So we've just skipped forward a little bit there. So let's wander back. So I work on the Microsoft team at Elastic. So much like Elasticsearch being a distributed system, the team is also distributed. So I'm based down here in Sydney. Then my colleague Martijn is up in Amsterdam, and then Greg is over in New Jersey. So we're also highly available and fault tolerant as well. So if one of us becomes sick, we can still carry on working. Having a few clicker problems. And we work on Nest, so the .NET Elasticsearch clients. There's actually two clients. There's a low-level client, Elasticsearch.net, which is very unopinionated, basically sends HTTP calls. The Elasticsearch API, which is quite large, is all mapped within Elasticsearch.net as individual synchronous methods and async methods as well. Then there's a high-level client, Nest, which uses strongly typed requests and responses. And that's the one that I would generally recommend you go and check out and go and have a look with if you're using .NET to interface with Elasticsearch. And we also work on the Windows MSI installers. So these are coming very, very soon. So they're going to be MSI installers for Elasticsearch, Kibana, eventually Logstash and Beats perhaps as well. And these are just a more native feel for being able to install Elasticsearch on Windows machines. So if you're installing onto Windows servers using something like Chocolatey, those can then use the MSI installers to do that. I think we may need some new batteries for this remote. And then finally, the last thing that we work on is the Azure Marketplace. So we have an ARM template in the Azure Marketplace. That's also available on GitHub. That's an open source marketplace template. And that's really what I'm going to be talking about and concentrating on here today. So just a kind of a quick hands up. How many of you have heard of Elasticsearch before or are using Elasticsearch? Awesome, quite a few of you. And how many of you have developed ARM templates before? Okay, a couple of you. And how many people haven't put their hands up already? Okay, the minority. Awesome, awesome. So first of all, it kind of makes sense just to talk about really what the Elastic Stack is, just for those that may not be familiar. So the Elastic Stack is basically software that makes searching through structured and unstructured data incredibly easy. And this could be for a number of different use cases. This can be for your typical classical application search. So I have a collection of products or items, and I need to be able to provide to users the ability to search through those items intelligently. So Elasticsearch is a good fit for that, good use case for that. It also can be used for a centralized logging solution as well. So you have all those IIS logs, all those application logs, maybe firewall, antivirus logs within your infrastructure, taking those to a centralized location so that you can monitor your infrastructure. And then finally, it can also be used for analytics and finding anomalies within your data sets. And that's kind of part of what the Elastic Stack is. So there's actually a collection of different pieces of software. So starting at the top here, we have Kibana, which is the UI user interface for looking at data within Elasticsearch, for building out visualizations, for building those dashboards, those real-time dashboards. You would use Kibana for that. And then we have Elasticsearch, which is obviously the search and analytics engine where all the data is going into. Then we have a couple of products, Logstash, which is very much like a rich ETL tool, can take data from a number of different inputs. So this can be queue storage, this can be files, this can be Elasticsearch itself, it can also be SQL Server, and it can take that data, you can then transform it and enrich it in various different ways, maybe take data from different sources. So if you have IP addresses in your data set and you want to go and get the geo-IP data for that, the country code, etc. Logstash is able to do that for you, then can output that to various different places, one of them being Elasticsearch. You can also output it to queue storage, to files, etc. as well. And then we have Beats, which are very, very lightweight data shippers. So these are written in Go, they're very, very small memory footprint, and you would typically run those perhaps on all of your nodes and use those to be able to send data to Elasticsearch. So very much in the kind of the Unix philosophy, do one thing and do it well. We have a multitude of beats that do various different things. So for example, we have FileBeat, which is able to look at a file and tail that file and send those log lines to Elasticsearch. You have MetricBeat, which is able to take metrics. For example, if it's on Linux, it can take those using the top command and then send details about CPU stats for that server to Elasticsearch. Windows specifically, there's WinLogBeat, which is able to look at the event log and send those data to Elasticsearch. And then we have on the right-hand side, so all of that stuff I've talked about so far, that is all open source. You can go out there, you can use that, you can download it now, go and play with it, build something in production with that stack. That's all licensed under Apache 2. On the right-hand side here, we have the XPack, which is a commercial set of extensions that Elastic offers that extends the capabilities of the open source stack. So this is doing things like security, so it's like Active Directory, LDAP integration. If you want to do document level security or even field level security, then XPack is a very good fit for that. Alerting, taking, when some stuff happens within a certain period of time, take some specific action, send something to Slack, send something to PagerDuty, send an email, index into another index into Elasticsearch. XPack enables you to do that. And then finally, down the bottom here, we have Elastic Cloud. Now, Elastic Cloud is our managed Elasticsearch as a service offering. So if you don't feel like you want to handle or take on the responsibility of managing an Elasticsearch cluster yourself, just let us handle it for you instead. Elastic Cloud currently runs in AWS, and there is another product which is going to expose Elastic Cloud to allow you to run the software that we use for Elastic Cloud in your own infrastructure. So on your own Metal, on your own private cloud, on Azure, on AWS, wherever you want to put it. So a very, very, very brief overview of what Elasticsearch is. I'm not going to spend too long on this because it's a very, very large topic. But I think it's important to kind of go over this stuff because it's going to give you some understanding of why the ARM template for Elasticsearch is such a large piece of work. So in essence, Elasticsearch is a search analytics engine. You interact with it over HTTP. So you send it a JSON document, and you get back a response, and it can store those JSON documents in what's known as an index in Elasticsearch. So an index then can be made up of a number of shards. So those documents are partitioned into shards. And you can run Elasticsearch over multiple nodes. So these are essentially just instances of Elasticsearch running in a cluster. So these nodes can be installed on individual machines. You can run multiple nodes on the same machine, and they together form a cluster. Elasticsearch forms that cluster for you and manages the state of that cluster. So here we have an index that has 3 shards, so 3 primary shards here, the P there for primary. And then we also have what's known as replica shards as well. So Elasticsearch, being a distributed system, basically follows the primary replication model of a distributed system, which basically means that there is a primary set of data, and that gets replicated to a replica set. So reason we want to do that is because if we were to lose one of these nodes, and we were to lose the shards on those nodes, one of these replica shards here would be promoted to a primary shard. The cluster would still remain operable. We haven't lost any data, and we can still keep using that. So then at some other point in time when a node comes back up again and joins the cluster, Elasticsearch will then balance the shards across the nodes, and happy days. Nothing is taken the cluster down there. So that brings me on to the ARM template. So that was a brief overview of Elasticsearch. So what is the ARM template? So ARM templates are basically just a JSON resource to allow you to deploy some resources to Azure. Now, the Elastic ARM template, which is up there at GitHub, it's open source. Feel free to contribute to it and send me some pull requests. That would be awesome. It was forked from this Elasticsearch Quick Start template. So for those of you that aren't aware, Microsoft themselves, the Patterns and Practices team, and one guy in particular called Trent Swanson, they put together all of these Quick Start templates to give you different examples for how to deploy resources to Azure. They had one there for Elasticsearch, which we forked with permission. We did ask. So we forked it for a number of reasons there. We forked it because we have a different release cycle to the Quick Start templates. Some of the features and some of the conventions for when you deploy something to the marketplace are quite different to what you need within Quick Start templates. So we can be responsible for our own release cycle there. Skipping ahead, there we go. So what does the ARM template actually deploy? So this is a very, very brief overview of what it will deploy for you. The things with the yellow background, these are the things that the ARM template would definitely deploy. And then the things with the white background are optional extras. You can choose to deploy these or not. So essentially what we have in Elasticsearch is we have a concept of different types of nodes that make up the cluster. So we have data nodes, which are where your data is actually going to be stored. So that's where the indices and the shards that make up the indices are going to be stored. So the template is able to deploy 1 to n data nodes. It can deploy as big a cluster as you want to. So if you wanted a 200 node cluster, the template can do this for you. The only thing that you're limited by is the core quota limit on your subscription. So if you've spoken to the guys at Microsoft and you have the ability to have 300 cores within your subscription, you could deploy a very, very large cluster there. So data nodes are where the data is actually stored. We also then set up an internal load balancer, and we also optionally deploy a virtual network as well. So we can either set up a new virtual network, but we can also deploy the template and deploy the cluster and attach it to an existing virtual network, which is very useful if you have applications that are going to want to interact with Elasticsearch. Then we can optionally deploy some master nodes. So master nodes, when the cluster is running, there is one master node there that's responsible for maintaining the state of the cluster and responsible for election leadership when new nodes join or leave the cluster. So we can optionally deploy 3 master nodes there. Reason for deploying 3 master nodes is if the master node ends up going down, 2 of those other master nodes that are eligible master nodes will then be promoted to be master. And then we can also deploy client nodes, which act sort of like smart routers within the cluster. They know exactly where to send requests within the cluster. And then we can also deploy Kibana there as well, so for you to be able to visualize the data that's in Elasticsearch. And finally, all of this is deployed into internal networks, so this Elasticsearch cluster is not exposed to the outside world. But you may need to be able to get onto those machines, in which case you have the option to also deploy a jump box that you can then SSH into in order to gain access to the cluster. So let's first talk about the marketplace. So I'm going to go through the bits that are involved in the ARM template and the marketplace offering. Feel free to stop me at any time if you have any questions. So what is the marketplace? So I'm just going to switch to my other laptop here and just give you a quick demo of the marketplace. So within the portal, we have this concept of the Azure Marketplace. And in the top here, we can search for pre-configured third-party solutions in order to deploy resources to Azure. So if we were to search for the Elastic Stack, here we are. This is our template. And then all the marketplace is effectively just a WYSIWYG kind of a GUI walkthrough, step-by-step walkthrough, in which you provide parameters, and at the very end of these eight steps, well, 7 steps and a confirmation, we can then deploy a cluster for you. So we just simply go through and we put in our username and how we want to access the virtual machines within the cluster, so give them a password. And pick a resource group, and so on and so forth. And then we go and configure the cluster, so which version of Elasticsearch, the name of the cluster, whether we want to set up a new virtual network, or whether we can choose an existing one in the same location as the resource group. So there's one here that I already have prepared. And we simply just go through all of those steps, and at the very end of it, an Elasticsearch cluster is deployed for us. So in true kind of Blue Peter or cooking show kind of programs, here's one I've prepared earlier. So if we jump down here and have a look at resources. So MS Ignite Blue Peter, here's one I prepared about 20 minutes ago. And we can get an overview here of the resources that have been deployed here. And if we were to then go and look at the Kibana IP address, which would be a public IP address, we can get the DNS of the IP address there, and then go and put that into the browser on port 5601. And here we go. This is Kibana that I deployed 20 minutes ago. And we can interact with Elasticsearch itself using the dev tools within Kibana. So I can perform a search on the cluster here and get some results back here on the right-hand side. So that's the marketplace and the steps that you go through in order to deploy Elasticsearch, but very, very easy to get started with. What kind of goes into that marketplace template? Well, actually, it's just a JSON file itself. And it's a JSON file with a specific name, create UI definition, and it really has these 3 different properties in there. So basics are the initial kind of username, password, SSH key that you want for your VM. So that's required for all marketplace templates. And then you have steps. Now steps there basically control these blades here. And within steps, you can have then a collection of elements. Now there are elements for doing various different things. For example, there's an element for a drop-down to give people different choices. There's elements for radio groups. So as developers, we're probably all familiar with the kind of the classic elements and controls that you normally have when you're building something out. So the marketplace provides those to you. And then finally, outputs. So outputs there is effectively just a set of key value pairs that get outputted from what the user has put into the template. And so the marketplace UI actually works together with the ARM template. So the marketplace UI itself is fed from this UI definition here on the left and generates the GUI that you see in the portal. And then the output of those just gets fed into the ARM template as parameters. And then it's the actual ARM template that does the provisioning onto Azure. But you can also interact with the ARM template from the CLI here as well, or the PowerShell SDK. So you don't actually have to use the market template at all. You can actually go straight to the CLI itself. And there are some really, really good reasons that you might want to go to the ARM template. And probably the primary reason is that we don't expose all of the parameters and all of the options that are in the ARM template in the marketplace. The marketplace is very much set up to be a get you started with running with Elasticsearch. So it has very simple configuration there, standard kind of configuration. But the ARM template itself can actually do much, much more. It can do things such as if you already have a pre-configured Azure storage account, you can configure that with Elasticsearch to use that storage account for snapshots and restores from the data in the cluster. That's one particular thing you can do with the ARM template. There are other things that we're working on currently. So being able to encrypt the disks at rest, so all of your data is encrypted. That's also being worked on. Being able to deploy an application gateway, so we can do SSL offload to the cluster. These are all things that are in the ARM template, but aren't currently exposed and probably not going to be exposed in the marketplace because it would make the GUI far, far too complicated to get started with. So there are some issues, unfortunately, with the marketplace. So Elastic hearts Microsoft like any love affair. It's not all roses all the time. So there are some issues with the marketplace. One of the major ones here is that you can only deploy into one resource group. So you can, into a new resource group. You cannot deploy into an existing resource group. This means that with the marketplace, if you were to deploy the template or deploy a cluster into one resource group and then decided, okay, I actually want to increase the number of nodes in that Elasticsearch cluster, you cannot go through the marketplace again and redeploy onto that existing resource group, which you can with the ARM template. So you can scale up and scale down clusters through the ARM template, but not through the marketplace. One of the other kind of niggly little issues is cross-property validation. So you cannot be able to say that if this property is X, then enable this property Y. You cannot do that in the marketplace elements. It just do not allow you that kind of control. And then the available elements there. So for example, if there's an element there for being able to set up an existing configure an existing virtual network, so attach it to an existing virtual network, or set up a new virtual network. You can also set up that element to just deploy to a new virtual network, but you cannot just have it to set to an existing virtual network. So there are some limitations with some of the controls there. And then finally, there's no integrated contact details in the marketplace, which means that we have to put up another blade there in order for you to provide us with details so that we can get in contact and see how things are going. So that's kind of the marketplace in a nutshell. Any questions about that? Yep.
My question is around the pricing. So how's the pricing? Is it different?
Okay, so the question was around pricing for Elasticsearch. So with the Elasticsearch template, you obviously pay for any of the resources that you actually deploy to Azure, so you'll be paying that to Microsoft. The Marketplace template itself deploys with a 30-day trial license of the XPack offering. So it deploys the open source Elasticsearch stack, and it deploys with a 30-day trial license of the XPack offering. Now, if you decide after 30 days that you didn't want that, you can uninstall it from the cluster. You can also apply for a basic license, which is free, and that gives you some capabilities in the XPack, in that XPack plugin offering. Or you can come and have a chat with us, and we can look at subscriptions. So on to the Azure Resource Manager. So I've kind of talked about it a little bit. What is it? So it's basically a consistent API to provision resources. Who's familiar with the classic Azure way of provisioning resources? Okay, a couple of you. Yep. So Azure Resource Manager came out in 2014 as a way of being able to deploy infrastructure in a more consistent fashion. So there are resource provider namespaces for all of the common different types of resources that you want to deploy to Azure. So Microsoft Storage, Office Storage Accounts, Compute for VMs, Network for virtual networks, network interface cards, that kind of stuff. And with resource groups here, you deploy all of your resources into one resource group. It's kind of like a container for a collection of resources. But the individual resources that you deploy into that resource group can actually go and live in separate locations. They don't have to be tied to the location of the resource group itself. So it means you can set up a resource group in Australia Southeast and then have resources in there in different places all over the world. So if you're a large company that needs to have resources with data locality to where it's being used, you can deploy resources there to those other locations. And so with the Azure Resource Manager, you can interact with it through the Azure CLI or with the PowerShell SDK. So here's an example with the Azure CLI. So we can go and create the resource group up here, and then we can configure a VNet. So we can just use a command, create a VNet, and then we can go and create a VM, and then we can go and create a network interface card, and we can go and create other stuff, so on and so forth. And we can eventually build up all of our infrastructure purely from the command line, which is awesome, but it could take us a long time for something like Elasticsearch. So this is where ARM templates come into it. So with ARM templates, we have the ability to declaratively deploy to Azure. So with our ARM template here, we simply specify the resources that we want to deploy. So here, virtual network, in the provider namespace here that we saw previously, the location for it, and then any properties that it needs to do. And then once we've got that template, that JSON template, we can then declaratively deploy from the command line as well. This clicker is really not loving me. There we go. Okay, yep, so back to the command line. Again, we create the resource group as we did with our imperative deployment. But now our second step is just to create a deployment of that template that we have. So create the template, we point it at the URI for where it can find our template. So if we've got it up on GitHub, we can just point it to the GitHub URI. And then we just pass it a parameters file, and that parameters file are just the parameters that are going to feed into our template. And once we do that, all of the resources that are in our template are provisioned on Azure. So much, much simple. Step 3 there is profit. I missed that one out. So a few kind of notes around deployments here. So if you are getting into ARM templates, there are a few sort of things to bear in mind. The first one is the deployments themselves are kind of transactional-ish. So a deployment either succeeds or fails in its entirety, but any resources that are already deployed up to that point are not rolled back. So you still need to go in there and tidy up any resources that have already been deployed up to the point of which that deployment may have failed. And then there are two different ways that you can also deploy templates as well. So I hinted at earlier where you can go and deploy an Elasticsearch cluster onto an existing resource group that already has the cluster in it. That's something called an incremental deployment. So you can just deploy over the top. So any pre-existing resources that are not in the template, so i.e. the cluster that already exists there, is not going to be touched by that new deployment. It's going to provision new resources for you. Any changed pre-existing resources are going to be re-provisioned though. That's an important point. So if you do make a change to the parameters in the template that affect the existing resources, then they will be re-provisioned as well. And then you also have the option to do a complete deployment there as well. So with a complete deployment, if you were to do that into an existing resource group, it will blast all of the resources there. They all get deleted, and then your new resources are going to get provisioned on the top. And as I said earlier, we forked our template from the Elasticsearch Quick Start template. If you want to know more about ARM templates and have a look through those, go check out the documentation here and all of the different templates and different examples that they have here. And the link down the bottom here, deploy to Azure, this can take the template that exists in that GitHub Quick Start templates repository. It can take that template and simply provide you a very, very simple interface to input parameters into the template and deploy it straight from GitHub. So, time to get down to the nitty-gritty, and we're going to start talking about some of the internals for those templates. So there's a few sections to kind of talk over. So with our ARM templates, kind of four main sections really: parameters, variables, resources, and outputs. So parameters are just a way for you to be able to provide the user with a way to input various different options into your template. Straightforward enough. They have different types. And then we can then use those parameters with this parameters function here. We can simply use those parameters there within our template. So we can use it for anywhere from this point onwards, from variables onwards. We can use those parameters. So we provide them here with a way of setting the VNet name. And the next section is variables. So with variables, these are kind of like an internal way of being able to modify perhaps some of the parameters that you allow and expose to people, and do something different with them, or concatenate a string, or produce a unique hash, or do something else with them. So in this particular case, we provide the way of being able to provide the user with a way of providing us a prefix for the virtual network, and then we concatenate that prefix there with a unique string here across the resource group ID and the deployment name. And that unique string then is going to give us a unique hash for this particular deployment in this particular resource group. And then we use that variable name, that VNet name, there as the name for our virtual network. So all kind of pretty straightforward stuff so far. Then we have resources. Now resources are what you might expect. This is where we're actually going to provision the resources into Azure here. So this is an array of resources. So in this particular example, we are actually going to call out to another template here. So in this particular one, we have this create network resource, and it's going to call out to this other template here. So this is a linked template. So this is a way for us to be able to break down and separate the concerns and separate the resources within our template. So we can call out to other templates here. And then that template there will have its own parameters, variables, resources, and outputs, and it can feed back stuff from there to the template that called it. And then finally, we have outputs. So outputs are a way of being able to provide outputs from the resources that have been provisioned in Azure. So in the case of the Elasticsearch installation, we have three outputs depending on, we have three outputs, and depending on what you've deployed, we might send you back the IP address for being able to connect to Kibana, or the IP address of the jump box, or the SSH public key that you used when you deployed the template. So if you're deploying from the command line, this is very useful because you can then take that Kibana IP address or those outputs, and you can then feed those into other parts of your DevOps automation. So we can then reference those outputs. So if we have a link template, or so if we have a link template, we can then reference those outputs from other templates within the outer template. So here, that create network resource that we were calling out to, that link template that we were calling out to, we can get the output from that template in the template that called it. And then we can pass that back up to any other templates that may have called it as well. And then resources themselves have outputs. So for example, if you deploy a storage account, there is a function called list keys, which will give you one of the API keys that you can then use in order to interact with that storage account. So that's one of the outputs that you can get there from storage accounts. And then finally, as I hinted at, template outputs. So if you deploy within the marketplace, after that deploy has succeeded, we can go to the deployments tab there for our particular resource group, and then we get the outputs here from the actual template itself. So that's kind of a brief overview of the main sections of an ARM template. So let's kind of look at what options and what tools you have in order to control flow there. Because when I talked about the cluster earlier, I said that we have the ability to optionally deploy Kibana, optionally deploy a jump box or an external load balancer. So how do we actually achieve that? So we have the ability to branch within ARM templates using this kind of hash construct here. So in this particular case, we have a parameters user input that has a couple of different options. So the template, if you're going to use this template, you can only provide one of those two options, otherwise it's invalid. And then based on those two options, we have this variables here, this options variable, which has option 1 and option 2. And with option 1 and option 2, we have two different address prefixes. Then what we can do is we can index into that variable's options with the parameter that was passed in order to get our specific options object out there into our option variable here. So it's basically like a hash map, like a dictionary hash map, in order to get the particular configuration out for the parameter that was passed in. And then finally, we can use that option variable here for the address space for our virtual network. So that's how you achieve branching within ARM templates. And then you can use that then to decide which, so I talked about link templates. You can then use that to decide which link templates actually get deployed. So in the case of Elasticsearch, if you decide you want to install Kibana, there is a create Kibana resources template. If you decide not to, there's actually a create an empty Kibana resources template. Now, the important thing here is that the actually go and create resources and effectively a dummy empty resources template, they both have to have the same parameters to them. If they don't have the same parameters to them, the infrastructure is not going to like it and your template will not work. So that's one very, very important thing. The other important thing is that both of those link templates, so if you have one that actually deploys resources and one that doesn't, the outputs of those templates also need to be the same as well. So the parameters and the outputs need to be the same. One's obviously going to be full of resources that get deployed, and one's going to just have an empty resource set there. So in this particular case here, we are deciding whether to deploy a new network or use an existing network. And then based on the parameter that the user has passed in, we can decide which template we're going to end up using here. So the existing network there is going to be empty there because the resource already exists in another resource group in the same location. So that's kind of branching and then how we decide which templates we're going to use. There's also the ability to loop there. So I talked earlier about Elasticsearch Cluster being able to deploy one-to-n data nodes, one-to-n client nodes. So we achieve that with something called this copy object. Now, with copy object, we just simply set it up with a name, and then we can set it up with a count. And then it's going to deploy this resource, this count number of times. So we're going to get that number of instances of that resource. So this is how we achieve being able to deploy n number of virtual machines. And this copy index function here, which goes hand in hand with this copy object here, simply gives you the current iteration number, the integer, upon each calling. So it's kind of sort of XSLT-ish like in its kind of nature. And obviously, if we were building a more complicated template here, this count parameter here is going to be, could be one of the parameters that your user has passed in there. So I want 10 data nodes. We can pass that parameter in here to this loop. And then the other kind of thing that we have here are dependencies. So in the Elasticsearch template, we need to be able to set up storage accounts before we go and deploy any virtual machines, because the data disks are going to go and live in storage accounts, so they need to be there before we start provisioning VMs. And we do that with dependencies. So by default, if you don't have any dependencies using this depends on property here, all of the resources within that resources collection, they're all going to be deployed concurrently in that template. So with depends here, we can break up that concurrency, and we can say that this thing depends on this other thing. And if we have a resource here, like for example storage accounts where we're deploying multiple instances of that resource, we can say that we depend on the name of this copy object here. So this is where that copy name actually comes in handy. We can say wait until all of those storage accounts are deployed before actually deploying this virtual machine here. So a few kind of words of advice on dependencies. Because they are then going to serially deploy resources, you obviously don't want to do it unless you truly depend on those other resources. So if you decide that you put depends on in there when there isn't truly a dependency there, your template is going to take a lot longer to actually deploy. So we've kind of talked about the ARM template and the various tools, options, functions you have there for being able to configure that template and which resources are going to be deployed. But I haven't really talked about how we actually get Elasticsearch onto the VMs that we've just deployed. And this is where you have a few different options. So you can decide to pre-bake virtual machine images and use those pre-baked virtual machine images when you deploy those VMs, or you can use one of the VM extensions. So VM extensions are pretty much exactly what they say on the tin. They are extensions that run on virtual machines after they are provisioned. So there are some benefits to pre-baking. You get faster deployments. Attaching disks is very, very fast. But they're obviously less flexible, and every single time that you want to use a new image, you have to upload that to a staging environment. It has to be approved by Microsoft. They have to give it the thumbs up, so you're not doing anything nefarious. And once that's all done, then you can start using that image. For something like Elasticsearch, where we release new versions, a lot of the time, and where we are, as a team, we are constantly upgrading and updating that template to add new features. Using VM images is actually not that good for us. So what we do is we use VM extensions. So we can just simply change the extension there, add in those new features, and it's in the template, and away we can go. But it does mean that the deployments for us are a lot slower because it has to run the script every time. So we use this custom script VM extension. So when we deploy Elasticsearch clusters, we deploy currently to Ubuntu. It's on the roadmap there to also deploy to Windows servers and perhaps to some other Linux distributions as well. And we use this custom script for Linux here. So we simply point it at a bash script, and that bash script there has all of the steps in there to deploy the template. So first thing is to download Java, because Elasticsearch is a Java application. I'm here at Microsoft Conference talking about Java, which is awesome. This is why we have the open source track. And it will download Java, and then it will download Elasticsearch, configure Elasticsearch and all of the settings for that, do any other kind of configuration that it needs to do, and then actually, once that's finished, then that VM extension then reports back to the Azure infrastructure to say it's finished running. So there's a few interesting things that we do need to do in the template. So if you decide to deploy an internal load balancer and an external load balancer, two load balancers cannot talk on the same backend port to a collection of virtual machines. So we actually have to do some rerouting on the virtual machines in order to reroute from one port for the backend load balancer, for the external load balancer, in order to talk to Elasticsearch that's on another port on those VMs. So that's kind of one of the fun things that we have to do in that script. And there are a few other things, unfortunately, that we do have to do. So this picture here is what I imagine WA agent or WA agent is doing on the individual boxes. So WA agent or WA agent is the agent that runs on Linux distributions in Azure that reports back to the fabric on what is happening on the box. And we have had some fun times managing the WA agent in order to make that work properly. We have seen lots and lots of failures with deployments that have looked very, very happy, but being reported back to the fabric as being failed. So what we ended up doing here was actually managing the WA agent to effectively kick off that service, forcibly just kick it off after we go through each individual step within our script. So download Java, kick off WA agent. Download Elasticsearch, make sure WA agent is still happy. So that has been a very, very fun time. The other thing to bear in mind is if you are using script VM extensions, is that your scripts need to be idempotent. So if you're deploying again, your script will run again. So you need to make sure that if it's running on a VM that's already been provisioned, that script is not going to change anything. It's not going to download Elasticsearch, download Java, et cetera, et cetera. You need to make sure your scripts are idempotent there. And then package manager failures. We've seen quite a few instances where using apt-get, the package manager for Ubuntu that we use to download Java and download Elasticsearch, we've seen a few issues with that just being unable to go and get packages for seemingly no obvious reason. So we've had to build in retries there to re-download, attempt to re-download that package, attempt to re-download that package if it fails. So we've had to build quite a fair bit of resiliency into our scripts there. And I think Microsoft is aware of this as well, because in October, they came out with custom script for Linux version 2. So if you are deploying anything on to Linux boxes now and you're using a script to do so, definitely use this thing. It's not based on WA agent as the previous version was, and we have seen far, far fewer failures with this. And if scripting to get your software onto VMs is really not your thing, then there are also other VM extensions here as well. So for example, you can use PowerShell DSC in order to configure the desired state of those VMs at startup. And then you can also use things like Chef and Puppet, and our good friends Octopus Deploy there as well to also configure the state of those VMs. So you have a lot of different options. So kind of on to some of the issues with ARM templates. So I'm kind of going to go through this, going to explain some of the stuff that we do, and then I'm going to tell you about some of the issues. And some of the things that kind of personally get to me a little bit about the ARM templates are that they are kind of declarative, but then they're kind of also imperative in many ways. So when we talked about those sections where you have parameters, variables, resources, and outputs, once your variables are defined in your variables section, you have no way of redefining them. If you want to redefine variables, what you're going to have to do is build a link template, call into that link template, have another variable section in there where you may do your changes, and then have your resources there that you're going to deploy, and then go back out to the outer template. So that's kind of one of the things that, yeah, is a little bit frustrating, but things are constantly improving. The other thing is pre-flight validation checks. So when you upload a template to the marketplace, and you run through all the steps, and then at the very, very end, you hit go, the Azure Fabric itself runs through a bunch of pre-flight validation checks that basically runs through the ARM template to say, is this template in a good state for you to be able to deploy to the subscription and the resource group that you're deploying to? So this is going to check things like the number of VMs that you're asking and the size of those VMs that you're asking to deploy in a template. Do you have enough core quota limit in the subscription to deploy that? And if you don't, it's going to tell you before even trying to deploy it. That's awesome. Unfortunately, there are some things within the ARM template that are undocumented that break those pre-flight validation checks. So, and unfortunately, you don't know about them until they're broken, until you've uploaded a template to the staging area and they have broken. Manual mapping, this is another thing that I hope is going to be worked on, is that currently in our template, we have the option to deploy to various different VM SKUs, so various different sizes. And then we also have the option to deploy a different number of attached disks to those. So you can have a really, really powerful machine and then just only have a very small disk on there, or you can have medium machines with powerful disks. And then we can also choose premium storage, so SSDs, and we can also choose standard storage as well. Currently, we handle all of that mapping for all of those different VM SKUs. We handle all of that in the template. It would be awesome if we didn't have to do that, and if it was simply in some way exposed within the ARM template itself. That would be really, really cool. And then finally, there are some missing functions in the ARM templates. Anyone tell me what they think this function here might be doing? Okay, so this is a function to find the maximum value of A or B. So to find the maximum value of A or B here, there is no max function, unfortunately, in the templates currently. So we had to devise this beautiful thing to do so. Hopefully, where we do the subtraction and the addition, we're not going to overflow the backing numeric value that they use for this. So far, it's working fantastically. So on to some tips and tricks for working on templates. Visual Studio Code is awesome. So if you're working on Windows or you're working on Mac OS or Linux, Visual Studio Code is fantastic. There is an extension there, an ARM template extension that provides IntelliSense for all of the for your parameter names, for your variable names, and all of the functions that are available in ARM templates. And then it also tells you, it's kind of also a JavaScript linter as well, so it will tell you whether things are not closed properly. So I totally recommend doing that. And then you also, of course, here have the terminal as well. So you can do things if you're using Node or NPM or Gulp or any other sort of JavaScript task manager or build automation tool, which makes sense to use because everything's in JSON. Then we can also call here and build, run tests on our template, etc. Another thing that you may be interested in doing is having your own logging within your ARM template. Now, the Azure infrastructure itself provides some logging, but some of the things that we've seen there is that if you go and look at those log files on the infrastructure, you end up seeing duplicate log messages in there, and it only flushes to that log file at various different stages, and it flushes asynchronously. So what we have seen is that you end up getting log messages out of order in that Azure provided log file. So we actually have our own log function in our script that does that Elasticsearch deployment, where we actually have the execution timestamp there and where all of the log messages are in order. So it's much easier for us to see exactly where something has gone wrong. So maybe, apt-get hasn't got that package, or something else has happened. And then we can also diagnose then the slowest parts of the deployment there. So currently with the template itself, it usually takes around sort of roughly 7 to 10 minutes on a good day to deploy a cluster. And because all those VMs are deployed concurrently, that's usually about the time for any sort of size cluster. Currently the slowest part there is actually downloading and installing Java. That roughly takes around 4 minutes of that time. The other thing to bear in mind, and I've touched on with linked templates, is separating your concerns. This is a very, very rough overview of what the Elasticsearch template actually deploys and how it deploys those things. So we start at the top here with main template, and then we gradually work down from main template. So with virtual machines, we deploy the data nodes. Has the user decided to deploy Kibana here on the right? If they have, call into the Kibana resources template. If they haven't, call into the empty Kibana resources template, and so on and so forth for client nodes, master nodes, jump box, internal or external load balancer, existing or new virtual network, and then the shared storage as well. This is very simplified because some of these resources, such as the virtual machines, also share other resources. For example, configuring an actual virtual machine, they all share a common template to do that because they all need to all deploy Elasticsearch, Java, etc. So definitely separate your concerns and separate your resources. It makes it much easier to work on and understand and build your template. Next piece of advice I have for you is kind of a little trick within the marketplace and ARM templates itself. So when I showed you those quick start templates earlier and we had that deploy to Azure link, that's a little magic special link that you can use yourself in order to be able to deploy your ARM template from any place that it is publicly hosted. So we use this special URI here, create template, and then we simply encode the template, encode the URI of where our template can be found, and then we get this very, very simplified GUI for deploying our template. So this is simply just looking at the parameters in the main ARM template that you have and giving you the options that are available for those. So highly, highly recommended if you're developing templates to put this link somewhere and use it to deploy. So when you're working on it and you've pushed a new version of your template up to GitHub, you've checked in your change, you can then go and hit this link and you can go and then check it out straight away. And Azure will pull the template and all the resources from GitHub for you or wherever you've hosted it. Other piece of advice is definitely have some automated testing in place for your template. So as I talked about, the two parts is the marketplace UI definition that you have, which outputs key value pairs, and then you have the ARM template that takes parameters and then does all the provision of resources. It's worth having a step in there just to make sure that the outputs and the names of the outputs from your marketplace, the UI definition, match the parameter inputs to your ARM template. Very, very easy to just make a very, very small change and for things to be broken. There's this very, very handy function available within the CLI to be able to validate a template. So you point this at where Azure can go and find your template, so some publicly available URI. And Azure will then send that template up to its validation service, validate that the template looks good, and then tell you whether it's good or not. So that's something else to build into your automation if you're working on templates. And then finally, there's a couple of things there that are worth doing. Actually, go and deploy your template as part of your testing, which is where group deployment create comes into handy, and deploy different variants of your template if there are various different parameters available. And if you really want to go the whole hog, you can also test, do browser testing in order to actually go and test the template and ensure that the template looks good within the marketplace as well. So you can use something like Phantom.js and Casper, or something like Selenium to go and drive the browser then to go and test that the actual steps and the GUI and everything looks good there. So you've worked on your template, you've got everything there, you're happy with your testing, you're now ready to actually go and release it. So what do? You go to another site, not the portal, you go to the publishing portal, and you go and get pre-approved there. So you have to be pre-approved by Microsoft if you want to put something in the marketplace, and register your company. And then once you've done that, you go and create a template solution, and you create a topology. So topology really is just a container for a particular type of template, and then you give that topology a version number, and then you actually zip up the UI definition, the ARM template, any other link templates, any other resources. You zip all of those up, and you upload that zip into the publishing portal. Then Microsoft will go and look at that. Sorry, before we do that, you then can go and publish that to a staging environment. And then in the staging environment, which your subscription will have access to, and you can also allow access to other subscriptions, you can then go and test out that staged template and make sure everything looks good and it deploys as you expect. And then once you're happy with all of that, you can then request to push that staged template to production. And then once you do that, Microsoft will take a look at your template, make sure everything's okay, and you're using best practices there. And then once they've done that, they will publish it and approve it for the marketplace. And then it will appear and be available for other people to use on the marketplace. And there are some issues with that, unfortunately, as well. Sometimes that approval process can take a couple of days. Sometimes it can take a couple of weeks. And there are also different best practices to bear in mind as well. So if you are looking at quick start templates and following, and using kind of the patterns that they're using there, the marketplace patterns are slightly different. When you do have access to publish a template on the marketplace, you do have access to some resources that are internal, that are private, that will give you guidelines for best practices for marketplace templates. So there are some differences. One of the other things that happened to us, unfortunately, was we deployed to a particular version of Ubuntu and for Elasticsearch, and that particular Ubuntu image was unfortunately pulled from some regions in Azure, and we didn't know about it until we were told that some of these deployments were failing in different locations. So bit of a sad face around that. Yeah, it would have been nice to know that those images were not going to be there when we wanted them to be. And then again, on a kind of communication point there, you used to be able to, in the marketplace, to deploy to an existing resource group. So you could scale up and scale down a cluster. and then that just disappeared. It was no longer there, and yeah, we didn't know about it. So you can only deploy to new resource groups. So yeah, just a couple of things around communication. But I know that the marketplace and templates themselves are, they are going through constant evolution. There are new things coming out all the time for it. So, definitely watch this space. So in summary, I kind of talked about the ARM template, what Elasticsearch is, some of the good things for building ARM templates, some of the bad things for building ARM templates, and I started out by telling you all about the Elastic Stack. So in conclusion, really, there's kind of three things that I wanted to point out here. On the left, the Marketplace UI is fantastic to easily get started with Elasticsearch. Elasticsearch is so, so awesome. I'll give you a quick demo, actually. If I just jump back to my laptop here. So I talked briefly at the beginning around the .NET clients. What I've done just before I started this was I took, is everyone familiar with Stack Overflow? Yep, most of you. So I took all of the questions on Stack Overflow, every single question, every 13.1 million I think there are, and I took every single answer on Stack Overflow, which I think there were something like 40-odd million. And I also took every single user. So I took pretty much everything that's in Stack Overflow, and I indexed that into Elasticsearch on my trusty laptop here. And I'm just going to really just show you kind of how fast and how good Elasticsearch is. So I'm just using the .NET client here, and I'm just going to search across questions in Stack Overflow, and I'm going to look for the phrases John Skeet. So we all know who John Skeet is. He's kind of the Chuck Norris of Stack Overflow. He is the man who has answered the question before it's even been asked. So we're going to look for the phrase John Skeet, and then we're also going to look for the phrase Chuck Norris in the body of the question. And then any that do have John Skeet and Chuck Norris in there, we're going to highlight those. And then all I'm simply going to do is just dump those highlights out to the output here. So if I run that was how long it took. It took 1 millisecond to search through all of the questions on Stack Overflow on my local machine in Elasticsearch. We can see here at the top the query that was sent through. So the query is JSON-based query, and we can see the results that came back here. Now, rather than trying to read through those results, which are all in JSON, I've nicely just built a bit of a table down the bottom here instead that we can go and have a look at those. So I'm only looking at the body of the questions that came back from Elasticsearch and just where things have been highlighted in emphasis tags, using capitals as well because I've been a web developer since the 90s. So we can see things are super, super fast. So I just thought I wanted to show you that. So yeah, Marketplace UI, jumping back to this, Marketplace UI, very, very easy to get started with, get up and running, run Elasticsearch in Azure, and do some awesome stuff like I just did there with Stack Overflow with your own data sets. I'd say only use the Marketplace for proof of concepts though. It's great to get started with. As I said before, it doesn't expose all of the features in the ARM template, which is where the ARM template comes in. So it has all of these additional features. You have data locality if you deploy to Azure, so you can deploy it into the same location where you already have resources. You can attach it to existing virtual networks. You can set up VNet to VNet integration to expose it to existing web applications that you have. But if you don't want to manage this thing yourself and you don't want to administer it yourself, then there is always the option of Elastic Cloud as our hosted solution there. And we manage all of the upgrades for new versions of Elasticsearch. It's a one-click upgrade. I want to upgrade from this version to this version. And what we do in the background is we spin up a new version of the cluster, and then we migrate all of your data from the existing cluster there. And we also back up every 30 minutes as well. So that's really all I have. There's a couple of things I wanted to say. So you can go and win a Spark After Dark drone pilot pass by completing your session evaluation. So please feel free to give me your candid feedback. That would be awesome. Tell me which things you loved, which things you didn't love, which things I didn't explain well, which things you thought were awesome. The baby picture, probably. So tell me about those things. And finally, thank you very much. If you want to come and chat to me about anything Elastic Stack, I absolutely love our products. I would be more than happy to chat to you at length about anything to do with information retrieval, text analysis, analytics, any use cases that you have. Please come in and chat to me. I can be found at booth number 10. We also have coffee there as well. So we can grab a coffee and a pew and sit down and shoot the breeze for a couple of hours. And then you can finally find me on Twitter, @4loop, as well. Thank you very much for your time. It's been a pleasure. Any questions? Yes.
When you come from the market UI and go through all those 8 steps,
Yeah.
then do you get to see the actual template before starting deploy?
Yeah, so the question was, if you go through the marketplace UI and you've gone through all the steps and you actually deploy the template, do you actually get to see the template when the deploy is happening? The answer is yes. You have the ability to export the template that has the parameters, so the complete template that has the parameters in that is then going to be used for the deployment. There are some caveats to that. Some caveats are that not all resources in Azure are exposed in ARM currently. So there are some resources. I'm just thinking off the top of my head, I don't believe any of the resources that we use in the Elastic ARM template cannot be exported. So the entire template can be exported, yes. Yeah, that's a good question. Thank you. Yeah, so the question was, we currently deploy to virtual machines. Would it ever make sense for us to deploy to containers? Potentially, yes. So you had in mind perhaps deploying several nodes to the one VM, so having perhaps a powerful VM and multiple containers there and handling instances that way. Yes, I mean, there are pros and cons to doing that. Obviously, you can save on resources by having things running on the one VM. The downside is one of availability. If you were to lose that VM, you've lost the entire cluster. That's obviously one of the downsides. I think we probably wouldn't put it in the template itself, but because the template itself is open source and it's up and available on GitHub and you can see all of the different things it has, you are more than welcome to fork it and change it however you like to do that, yeah. Yes?
Elastic Cloud, is that available on Azure or are you hosting AWS?
So currently it's only hosted in AWS, which does raise some interesting things if you have the rest of your infrastructure in Azure. Obviously one around ingress and egress charges. There are plans to move it to make it available on Azure. And as I talked about at the very start, we have Elastic Cloud, which is our managed service, and we manage everything for you. If you are an enterprise customer that wants to basically provision clusters as we do with Elastic Cloud, we're actually working on something called Elastic Cloud Enterprise. The enterprise part, yeah. Elastic Cloud Enterprise is all of the software that we have and all of the infrastructure that we have to manage Elastic Cloud exposed to you as an end user that you can use to deploy clusters and provision clusters on your own private cloud, on your own public cloud, or on your own bare metal. So there is that option as well. It's currently in private beta, but if you would be interested in that, come chat to me and we can look at getting you involved. Cool, thank you.